Hi everyone. This is the second part of object-oriented Python programming. I wanted to recall the concepts and skills that we learned in the module 1. In object-oriented programming, we started with the classes. Based upon class, we need to construct objects. Through the objects, data in the class can be accessed. All right, so we have to first create a class, one or more classes as we want to design for a given application domain. From each class, there may be numerous objects to be involved, to be instantiated. So we construct on objects. So given an object, or specifically object ID, but in our in Python, the ID we were not able to carry over the IDs themselves. So we assign that ID to a variable. So we can handle the variable. But that variable is nothing but the object ID, identifier. For each object, according to a class definitions, there will be the data, multiple data available, and data can be accessed. And according to the class definition, where there is a method, the method in flat programming can be called a function, but in an object orientation, we call that a method. So a method can be invoked by an object ID. So that's what we covered in the module 1. Today we will collect them all in one program. Okay, so we'll do the review in holistic way, so that we can start with the class definitions. Okay, so here class department can be created. By the way, in object orientation, the class hierarchies can be also available, but we will not do that here in this level. But I want you to notice that there's another strong feature of object orientation, which is, for example, when you create a class, a person, then person can be decomposed into multiple subclasses, like professionals and hourly workers, or self, whatever that is. Okay, so multiple subclasses may be able to be considered for given a class. Another specific example in our well-known the domain, academia, then if we say person, then under the person we have a student. Student is another class, and then there's a faculty. There's another separate class, and then maybe a staff. That's also another class. Those three classes can constitute the academia domain. So on top we may have a person person first created. From that superclass, we can create a subclass like class student, class faculty, class staff. But each of such is not uh, independent class, but subordinate to a superclass called person. Then we need to say here whatever that is. For example, if we already have a person class, then we can say person, okay? But in our case, we defer that class hierarchies, okay? So they are all those three classes that we have: department, students, and the section. This is for course. They are all independent, and they sit on the same level. If we say about hierarchies, okay, they are all the same level of the hierarchies. Anyway, that is some other not directly related to today's lecture. So department class has two methods defined, but those two methods are like the which is double underscore method, or magic method, which means those method names are not the name that we easily called, like this method. Then add or calculate GPA, those are the typical methods. But method is starting with and ending with the double underscore, D double, then D under. They are not called by this name, but in this case, if it is init, then this is a method to be used to initiate on objects. So it is invoked when we call the class name, and also this D under STL for string. This is invoked when we access an object itself. Okay. So we explained that this is can be used for the instantiation object construction. This is for the access of that object itself. Without this, if we print object itself, then it gives us object ID, which doesn't mean much to us. So to avoid that, we can design. So the way that we design here in this return statements, it can be displayed. It can be returned when we directly access object itself. Okay, so we have department here, and also student. Student has also the magic method for object instantiation, and another magic method for the object the access. And the other two, the method here are the real method that is implemented for business logic. For example, student wants to add course, right? So it is invoked by a particular student, which is an object, right? So object dot add with the argument course, then course can be added to the students. Where it can be added, it can be added to self.course if we have self.course, is the static field in a class. In this case, student class. Student class, that is the variable here, the class variable that can hold given class, given course, whatever here, third parameter in this method definitions. So this can be maybe in this case, if it is the course, then we should say this is nothing but the list. If it is a list, then we can append it, right? And then the calculation GPA. So given the grades in a dictionary form, double star with the variable in a parameter definition in a method, then this method will take a dictionary form of input data. So we can get the keys from that dictionaries, and then for each keys, and we get the value, the grade. If it is A, then we can give 4.25. If it is A minus, we can give 4.0 for real the GPA calculations. So we looked at this earlier. And another one is here. This is for GPA for A students. And the for class or section here, then students will be a dictionary form, static element of the class sections. I can say here in a dictionary form. So again, we have here the construction method and also the object method and the real method for grading. Given grade, we can give letter grade. Okay, and now we can create an objects. So you can create, when you create the department, then if we use the class name itself here, according to the magic method, this underscore init function, init method will be invoked. Okay, that is what we mean by magic method. So when we invoke this magic method, then we need to use a department name, class name, with the arguments for department and chair. So if we look at here, the department, department name and department chair. So cyber department chair is Brian, and CS department chair is Chris. And then we also construct an objects with a class. So if we see the section here, section can be constructed with three parameters: student, student D, instructor, and student D. This is a student dictionary form. Student D means student dictionary. So it goes into that. So by the way, if we care about students in dictionary, then we need to say here student D and initial the point grade point is 0, so we can do like this. Then it'll be right. If we give, for example, John is a student. Here, initially, no students, right? Here in this case, we give dictionary itself. Therefore, we don't need to dictionary here, right? See here, dictionary. This is the first parameter here in the init magic function. Then we assume the data itself is in a dictionary. If we say this, then we don't need to say over there that curly braces. If we simply call value here, then we should say with that value, we have to create a dictionary form, the one that I earlier explained. And then we also construct an objects of students. Students needs three the arguments, right? So Bob, department 1. This is department 1 here. Look at the value for the second argument. There's nothing but the object ID, DPT1. And the third value here, that is in a list. So when we go back up to the students, therefore we don't need to put here the list format, because we assume this value itself should be in a list. So we don't need to do that. And the major here, that's the parameter value assigned to self variable here, self.major, which is the static field variable of students that which can hold the major, which is given by the color of that magic function. So the major here, we rather than say cyber, we send object ID. So not the department name literally, but we give the department object itself. Okay, I wanted to see the difference. Not literally cyber security department or computer science department, but we say, hey, your major is that specific objects. Whatever that object is constructed, that object total, that object and entire object is your department. So not just saying that, hey, what is your major? Then computer science. It doesn't say anything in addition to name itself. But in object orientation, if we say your major is whatever that object ID assigned to, then you can see, hey, I know what is my department chair, what is it my department's annual plan, what is my department's course list, what is my department budget, what is my department's whatever department's faculty list, all such things. Whatever available can be seen by that objects. Okay, so you can do this rather than literal name only. Object ID, you can carry over much more than name only. Same thing here. For example, this is a faculty. Faculty also same thing. Yeah, we will look at that a little later. Rather than saying John, if we have an object about John, which is constructed from a class called the faculty, then faculty first created, defined, and then we can construct an object with John's information. Then that is an object of faculty. When we construct an object of this, then we can, rather than saying the name only, we can give the faculty object ID. Okay, so let me first comment this out, and I'm going to run this. So I want to see the students list. So I want to say student 1. But instead of whatever that object ID is given, this guy gives me student Bob in Cyber has the classes empty list. The reason that I have this result is because then I need to see the students, the init method. So when I go up here, the students init method, magic method. Oh no, the string method. The way that I described here, that is returned. The way that I want to show is students in the department has class something, okay? But if I don't need to say about the class, then students, the particular students in a department, then we don't need to say about the course. Only this. And then if I run this, then it shows here, student Bob in Cyber, student Chris in computer science, student Chris in computer science. Where is it to? Oh, we have 2 Chris's. So let's say here, yeah. Okay. Now, for this students, we want to. So now we know students. The object, students object is created, and let's invoke the method. Students wants to register, right? So we want to add a class. Into that add class, we can say, I want to add like this, student 1, student 2, student 3. I want to add, when we add the class, the arguments value for that add method is not just a literal the course title. Rather, we want to give object ID, because the CISC 131, that is an object ID here, which can know not only that course is Python, but also who teaches that course, what other students are involved, things like that, okay? So we use this object ID when the students wants to add a class, okay? So okay, so this guy wants to show again here simply whatever students object ID, same student object ID, but we added the students the classes. Therefore, if we change the way that we want to describe here, the one that we want to show, or when we add this, I want to add those guys into here student section. The section has students. So we want to assign the students self. So the way that we want to assign, well, this is a good the exercise. Rather than having this, okay, I want to show. No, I want to copy this, and here the courses that we have here, CIS 131, 231, 500, 455. So yeah, those. So CISC 131, 231. Okay. And then I do not want to show this. So right now, if I run this, then students enrolled in Python taught by John, but we don't have, although the students added the course, but when I come to the course itself, course does not have that the students list, right? So to fix automatically, if students wants to add, then not only the updates of the field name here itself, but we want to update self course. Course is a CRS. So if we go to course itself, course has students. So we can say students, and then, oh, this guy. Then we can say student name should be initially that self dot name colon, and then initially the grade is 0. Right? When we add the class CRS, then student information, then this students registered that course. Fine. But at the same time, student registration should reflect the course side also. So here in the section, there's a student list. So that students should be added to this student list. But when you see this student list, then that is in a dictionary format. So to add into the dictionary format, then we need to say self.name. This is a key, student name. Self.name is student name here. So into that, the value for that catalog is name colon whatever the points. So the key is the students, and whatever the grade, depending upon the grade, we can assign the. Let's see, grade, student's grade. Yeah, initially we simply say 0 points rather than, yeah, see what happens. Course. So course is not, let's see here. List object has no attributes. Course is a list, right? Course is a list. Course is a list. The students append the course list. Let's see. See what happens. Okay, if we simply say that, then it works that way. But if we want to, so course is a list. If we want to update, then we don't need to do we don't need to do we don't need to go to students course, student section. What we want to update is the section object itself. So we don't need to traverse from student.course.students. We simply that CRS. CRS is the object of that class. So that class has a student list, student information, which is in the dictionary. But CRS itself, this is not it's not yet an object ID. Also, although it holds object ID. So watch this. Why I am trying to say, if I do this, then okay. Bob S0. Let's see. So actually what we need to do is we simply say 0 here, right? I believe. We don't need to say that. Simply this. Okay, perfect. So then students Bob enrolled in Python taught by John. So what I did here, I simply add, right? For each student, we add something. And I want to add one more here, student to the not 130, not 231, 131. So I want to see the class 131 has two students, student 1 and student 2. Okay. So the student 1 that has Bob initial grade is 0, Chris's initial grade is 0 in a dictionary form, enrolled in Python taught by John. That's that makes perfect sense, right? Because here student 1 Bob first register CIS 131, and then later Chris register the same course, CIS 131. So Bob and Chris both are added to an object in a section. Okay, when I invoke a method in students that can reflectively to propagate to update on object in another section. That's what I showed to here. How it was propagated, it was propagated in this way. Okay. Not only updates my own object field, but another class object, which is anyway, CRS is another class object, right? So we add the initial value. And also, for example, if students take a grade, so we say grading self dot CRS endpoints, then then we can say self.course of the CRS dot student's self name points. Then that student's points itself can be updated. So after this, if I say student 1 dot grading, and for example, CIS 131 is 99 points, CIS 455, 88 points. Initially, Bob's grade 0 for Python course and also CQ coding course. Both are initially 0. But I want to update that grading, and then it should be changed. So I want to copy this and show here more. Listen, this is, yeah, that is this the Google advisor is not correct. Let's see, course CRS. Then this is a course, particular course, right? And then in self.name. The way that we can debug this, we can do like this. See what is of course CRS. Okay. And let's see, run. List indices must be integer or slice, not section. Oh, that's right. So, right, it should be like this. So what we need to do is, because course is simply list. So list can be accessed by index, not course itself. So the way that we can show here is if CLS in self.course, then we can say self.course dot index CRS. It gives me index. So that index should be, this is an index. That should be used for that index. So this index should be used here. Okay. Let's see if it works. Yeah, it should work. So we know that didn't give me index, print index. So when it goes to here, it should print. So grading. So first of all, that is the addition, and here, oh, what did I, students want the grading. So CIS, why there, oh, this is a graded, added more and more. So I want to, this is a, because I add more and more, right? So involved in this. It's Bob. It's a little bit confused. So Bob. Oh, I think these two things was printed by this guy itself. So I don't need to print this anymore because this is confused. I want to directly to students to add. Okay, so when I come back here, then remember here that Bob's new points 99 to Python class, and Bob's 88 go to secure coding class. Okay, why this is confused? Because each class we define the magic function str. If we remove this, then we may be able to see the object itself. But when I call this object, then it tries to show everything about this. So we can assign more and more. The thing is this, course in this student field variable is in a list. So this is in a list. Okay, so and then so to that list, if one student wants to update the course, the grade, then we need to first find out the course list. From the course list, we need to see which specific course that I want to deal with. So we need to get the index. Index is a given the function that associated with the list data formats. So given the course, then we can get the index. Now we can pick that specific index and the specific course, because students might have a multiple course to register, right? So I want to pick one specific course. If we go to that course section, then course section has a student list. So course section, and I want to go to student list. Student list is in a dictionary form. To access this dictionary value, then we need to give a key. What is the key in the student dictionary? There's a student name, student ID, and student's object ID. So which is student.name. No, not object ID, student name. So given student name in the dictionary, then I can update with the new points. So it is updated. I know this is the concept is not simple, but therefore you have to think very carefully to get the goal. Okay, finally, who is the director of a Bob's major? Then we can see, for example, student one's major. Then we need to see student one. Student has, if you go to student here, student has a major, right? But major, the value to this major field, when we constructed, remember that we used the student major, we used the object ID, right? Therefore, we can simply say student one's object, then this is not just a literal object name, but there is an ID. So if we go to the department, the class, then we can traverse from this object ID to specific field values within that class. So let's go to the department class to see the department chair. So if you go to department, then department name and department director. So we simply say department director here. So we can see the department. So Bob's department director is Brian, right? Because Bob is in, where's the Bob? Bob is in department one. Department one's director is Brian, right? that long story of the objects within this coding list, we can access very quickly, very straightforward way in one statement. Okay, simply like this. What if we want to do? If we want to see all the students' department chair, then we need to do here student list. Now we have students 1, 2, 3, and student 4, right? We have 3 students or 4 students. Let's see. Oh, we have 3 students. For these 3 students, no, I want to print students department name. What I want to do here, major dot director advising each, and then each dot department name. So what I want to show here, Brian is advised. Brian, so this is director. Brian is advising students Bob in cyber. In the cyber department, because the cyber itself is, I believe, because of that string magic once. So Bob is here, right? So what I want to do, if I change students self list here, I want to comment this. And if I want to return only self.name, student name only, then it gives us clear statement. Brian is advising students Bob in the cyber department. I want to change department chair of Chris because it was confused. So I want to say here department chair in CS department is Peter. Then I can get here. Brian is advising Bob. Peter is advising Chris. Peter is advising Charles in the CS department. All right. And I have a homework 6.1. This is big homework. I want you to consider that here. There's one small to-do list. When a student register a class object should modify accordingly. We already did that, right? We already did. Here, when students add, then we also touch the course student list in each course. All right. The concept of object orientation is realistic. It is very, very practical, but in coding, it's not. You may be confused unless you understand it clearly. Okay. So as you learn this, then you may catch the concepts how an object can be propagated from one class to another class and another class in one statement. That is very, very important, right? In one statement, we can multiple other object each from different class can be connected each. So example for that is this is an example, right? And in the coding, there are also examples. Yeah, this is kind of example that that you need to catch. Those are very, very, very that requires you to understand the object orientation paradigm. All right. I hope you can catch it sooner. Okay. Thank you. See you later.